Okay, so this is number 3 from the practice quiz. The first thing I'm going to do is write everything in terms of sine and cosine. And I decided to do that. I decided that that's a good first step because I have cosine here and here, and tangent's kind of the oddball. So we'll go ahead and write tangent in terms of sine and cosine and see what we can change here. So we have cosine times tangent is sine over cosine. And anytime I have multiplication like that, it's helpful just to write the cosine over 1 so that we can think about that as multiplying across. And then I have minus 2 cosine squared equals negative 1. Cosine times sine divided by 1 times cosine is what I have as that first term. And there are cosines. Cosine over cosine is 1. Those are going to cancel. It's not illegal to cancel there, and that we really are doing division. It's not illegal to cancel because we're really just simplifying a fraction. We're simplifying the fraction cosine times sine over cosine to sine. So we have now sine of x as our first term, minus 2 cosine squared of x equals negative 1. Since I see sine and cosine in the same problem, I know I can change either cosine into sine or sine into cosine. But I can only do that with squareds. Remember, sine squared plus cosine squared equals 1. But sine plus cosine does not equal 1. So you can only use the Pythagorean identity. Don't square root everything because that is actually not a true statement. That's not an identity. So at this point, what I can do is take this cosine squared and turn it into 1 minus sine squared. Remember, since sine squared plus cosine squared equals 1, if I want to figure out what cosine squared is equal to, I would subtract both sides, or subtract sine squared from both sides. So that would give me 1 minus sine squared. So everything else is going to stay the same. And then I'm just going to turn my cosine squared into 1 minus sine squared. It's good to always drop that in parentheses. It's good to always drop that in parentheses so you don't mess up the coefficient situation, especially here. So here we have this negative 2 that needs to be distributed in. So I'm going to leave this sine of x out front. All right, so now I have everything in my problem in terms of sine. And since I have a squared term and a to the first term, I know I'm going to have to factor. So I want to get my problem kind of in a nice order for factoring. The other thing we always have to do if we are going to factor is set our problem equal to 0. So I'm going to add over this 1. And then I'm going to switch around the order. I'm going to put my squared term in front. I'm going to put my to the first term in the middle. And then negative 2 plus 1 is negative 1. And now we're in a perfect position to factor. Go ahead and pause the video and try to factor this. I'm going to do that on the next page. So I'm going to pause and add a page here. So hopefully when you factored, you got 2 sine of x minus 1 times sine of x minus 1. If you're struggling with factoring with these problems, here is my suggestion. I suggest that you make this into use substitution. So if back from our last page, we had 2 sine squared of x plus sine of x minus 1 equals 0. So if you're struggling with factoring that, I would make it into this. That looks much easier to factor. Just kind of, it's not about it actually being easier, it's about the way it looks and it looking more familiar to you. So then you can factor by splitting the middle since you have a leading coefficient. So you do that's other than 1. So you do 2 times negative 1 is negative 2. Two numbers that multiply to negative 2 and add to positive 1 are positive 2 and negative 1. So it would look like this. plus 2u minus 1u minus 1. And then you could split it in half and factor 2u, u plus 1. Oops. And then we can take out a negative 1, u plus 1. So our factored situation is 2u minus 1, u plus 1. And that shows me that I actually had a sign off up here. Sorry about that. So if we go back up to our problem, we should have sine of x plus 1 up here. There we go. And then at that point, you can put signs back in for your u's. But hopefully that will help you with factoring. Again, these are no harder to factor than the trinomials that you dealt with in Algebra 2. I think sometimes they just look really difficult. All right, now that we have everything set equal to 0, we have everything broken up, we can set each part of our equation equal to 0 and solve. So 2 sine of x minus 1 becomes sine of x equals 1/2. And sine of x plus 1 equals 0 becomes sine of x equals negative 1. So where on our unit circle between 0 and 2 pi does sine of x equal 1/2? Well, that's at pi over 6 and 5 pi over 6. Since those aren't pi apart, we're going to write our answer as pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. And then for sine of x equals negative 1, that happens at 3 pi over 2. But nowhere else on our unit circle, so we're going to use plus 2 pi k there as well. So there are your solutions for number 3.